So up there on the board, you're going to notice there are two formulas because if you remember, last week we learned about another way to measure angles. And so we know that there are radians and there are degrees. And so we've got two different formulas based on that. Okay, and so those are the two formulas, S equals R theta, and S equals theta over 360 times 2 pi r. So the first one says find the length of the intercepted arc in each circle. Okay, when it says find the length of the intercepted arc, this just means find the arc length. Okay, so they put a bunch of words, but all we're finding is the arc length. The circle has a radius of 5 centimeters and a central angle of pi over 4. So with two formulas, you need to decide which of the two do you use in this problem. Which one? Do I use this one or this one? Top one, because pi over 4 is in terms of radians. Now it doesn't say radians, but remember whenever we have a pi, that always means radian form.
So the R in the radians up on top means the radius?
No, radius, yes.
Okay.
So our formula is S equals R times theta. So all I have to do is plug those values in. So R is 5, theta is pi over 4. So if you take 5 times pi over 4, your answer is going to be 5 pi over 4. Label will be centimeters. And there you go. That's your answer. Now, on your calculator, if you wanted to actually calculate that, you can take 5 times the pi button. The pi button is actually shared with the caret key. It's in blue, I believe. So you have to hit 5 and then the blue key and then the caret key, and then divided by 4. And when you do that, what does it come out to be approximately?
Okay, 5, second caret key, divided by 4.
Did you get 3.93 about?
Yeah.
Okay, 3.93 centimeters. So that's another way you could calculate it. You could just leave it 5 pi over 4, you could answer 3.93. Questions?
Okay, so when it says, when it's in terms of radians, that's when we use the S one.
Mhm.
That's what that
Yep.
thing is.
So let's look at this one. Find the length of the intercepted arc in a circle with radius 2 inches and a central angle of 60 degrees. So what formula are you going to use there?
Degrees.
The degree one. So the degree one says theta over 360. So in this case, 60 over 360 times 2 pi r. So times 2 pi times 2. So now let's go ahead and simplify things a little bit. I know 60 over 360 is 1/6. Okay? So I have 1/6 times, what is 2 times 2? 4. So really I have 1/6 times 4 pi. So simplify that. 4 pi over 6, which is really 2 pi over 3. Okay, that's one way. Or you can actually calculate what 2 times pi divided by 3 is. And what is that on your calculator?
How did you get 4 pi over? Oh, because it's a fraction.
Yep. So how do you do 2 times pi divided by 3? Or what do you get?
2.09.
2.09. Somebody else get that?
Right.
Okay. All right, so that's arc length. There's no tricks. That's just it. You have to identify radians or degrees to start with, use the formula, and go from there. Pretty straightforward. Now, area is once again just like it was with arc length. You've got two formulas. They're pretty straightforward. I'll let you go ahead and copy that down. We'll look at 3 examples and we'll be done for today. Now you're going to notice that the theta in terms of degrees looks real similar to the one we had for arc length. The only thing different is that the formula at the end is different. Pi r squared should be the area of a circle. Okay, so we're basically taking what fraction of the circle and then times the total area. So let's go and look at that first problem. It says find the area of a sector of a circle with a radius of 5 centimeters and central angle pi over 4. So this is the exact same problem we found the arc length with. So what one are we going to do? The radians or degrees formula? Radians. So all I'm going to do is I know that my area equals 1/2. What's my radius? 5, so I've got 5 squared times theta, which is pi over 4. So all I need to do now is calculate that. So in the numerator I have 1 times 5 squared times pi. Okay, what is 1 times 5 squared? 25 pi. In the denominator, what do you have? 8. Nice job. Label will be centimeters squared since you're dealing with area. You always need to square the label. What would it be decimal approximation?
9.1. No, 9.82.
9.82? Okay.
Centimeters squared.
Centimeters squared.
So they'll all be squared.
They will all be squared if they're dealing with area.
Oh, area.
Alright, let's look at another one. Find the area of a sector of a circle with given central angle and radius.
So it's radian.
Yep, good call. So it's the radian formula. So if you remember the radian formula, 1/2, and then what? Radius squared, good job. And then times
3 pi.
Now you're going to notice that this problem has both a fraction and a decimal. Whenever you have that, you need to answer in decimal form only. Okay, you can't combine a fraction and a decimal. So the easy way to do this, guys, 1.5 squared. Do that on your calculator. Did you do that? Okay. Take that times 1/2 or times 0.5.
1.125.
Okay. Take that times 3 times pi. And then divide it by 4. Just hit the division sign and hit 4.
2.65.
Somebody else get that? So
that's,
what?
that's saying that's 1/2 times 1/2 squared times 3
Pi over 4. Yes.
So you just do it all in one big thing without. But what do you do first? You do parentheses first with the square.
I just did the 1.5 squared first. It doesn't matter. You could do 0.5 times 1.5 squared. You just have to
You
divide all that by 4. Yeah. You could even treat the 3/4 pi as 0.75 pi, because that's what 3/4 is. You could treat the 1/2 as 0.5. Okay, so that could. Let's look at another one. Okay, find the area of a sector, central angle radius, theta equals 50 degrees, r equals 6 meters.
Degrees.
The degree one. The degree ones are going to be obvious because they're going to have a degree symbol. So if it doesn't have a degree symbol, you know it's going to be the radians. So 50 over.
360
Okay.
times pi 6.
Okay, now this one actually is one that you can do without pretty much using your calculator. Because we know that 6 squared is what, folks? 36. So really I've got my 36 here. So I know that I can cancel with 36 and 360, right? 36 goes into 360 how many times? 10. Now look at your 10 and your 50. 1 and 5. So really what am I left with? 5 pi. Good job. So 5 pi meters squared. If you chose to multiply that out, you could. In which case you'll get, what is it, 15.7172? What is it? 71? Okay. So that is area and arc length. That's all there is to it. Questions? Here are the problems you need to add on. Okay, 27 through 32, 43 through 48, and 58 through 61.